Now let's look at how to do digital inputs using our ARM processor. First off, let's look at how the digital pin works. Let's review this a little bit. So the first thing that we notice is that we have the clock gating thing here, right? So this is the part that powers the port. So we need to make sure that our clock gate is set so that we enable this particular port to operate. Then I want to make sure that my port control register is set to the GPIO mode, right? So this is the same as for digital output. I make sure that it's turned on using the clock gating. Then I make sure that it's set to the GPIO functionality, the general purpose IO functionality by writing a 1 into the PCR mux. Next, I want to go to the data direction register, and I want to write this as a 0 in this case, right? So the idea here is I want to set it up as an input. I enable the port, I set it to GPIO mode, then I set the data direction to input, and after that I can read straight from the port data input register, and that's all I need to do, right? So let's try this out in software. Let's try writing some of this code, right? I'm going to need to look up some things to figure this out. So before I write any code, I need to figure out where my switch is connected on the board that I'm using. So I'm going to use the user's manual and look through here and looking for switches. Let's see, I'm going to do a find for switch 1. It's not in here. Awesome. Great. So they didn't tell me where this switch is connected, what pin it's connected to. So I'm going to have to refer to the schematic. I found my push buttons. There's switch 1 is connected, is right here. So switch 1 is up here. That's good. And it's connected to signal switch 1. That's very useful. So let's go and find that. It's going to be somewhere along here. Ah, there it is. Okay, so I'm connected to PC port C bit 3. So switch 1 is connected to port C bit 3. So that's the port that I have to enable to make this work, right? So I need to set the clock gating for port C. It's not in that one. Here it is. Okay, so sim SCGC5 port C bit 11. Okay, so the first thing I need to do in my software is I need to set bit 11 in the SCGC5 register. I've already set bit 12, so I'm going to add another OR and do a 1 shift 11 there. So I'm setting. This is a little more verbose than I need, but the compiler is actually going to, because these are constants, the compiler will optimize those into just the literal value of their translation. So I'm just trying to be clear here. So I'm setting bit 12, which is my output. You can see that this is the same digital output program. This is my blinking program. So we're going to be doing something similar here. But I've set up this one turns on the red LED port, and this one turns on my switch port. The next thing I need to do is to set up my I'm on port C, so I need to set, and it's port C pin 3, and I need to set that one up as a GPIO. So I need to do the same thing that I did here. I'm going to copy all this stuff, but I'm going to reset it for port C pin 3. Awesome. Simple as that, right? So that's my first 2 steps is turning on the clock gating, setting it up as GPIO. Then I need to set up pin 3 of port C as input. And the way I do that is I write a 0 into the data direction register, which it is by default, but I like to be very clear in my in the code that I write so that I know for a fact that it's there. So if another program has written or it's in some unknown state, I know that I'm always writing a 0 into this thing. So what I'm going to do is I'm going to write a and a negative mask of 1 shifted 3 bits in. And what that does is it puts a 0 only in the pin 3 location on that particular one, because all the other bits are 1. Any ones that are there stay, any 0s that are there stay. Only pin 3 becomes a 0 in this case. So that one's set as an input, and I should just be able to read directly from it. And it's the pin 3 of the PDIR register. So inside of my while one, I'm going to delete both of these things because we don't need them anymore. I can say something like if P GPIO C PDIR, and I'm going to create a mask. If it's 1, the button is being pressed, otherwise it's not. So I'm going to bitwise AND it with a mask that has a bit only in the pin 3 location, and that is a 0 1. Sorry. It's a powers of 2, right? So 3 locations in, a 1 followed by 3 zeros is an 8, right? So my mask is hex 8. So basically, if this returns non-zero, if that's non-zero, which it will be, so it should be equal to 8. I can just say if it's non-zero, then it's true, right? So if that's true, then I want to turn on the LED, which means writing a 1 to the PDOR, PDOR register of port D. So GPIO port data output register, set a 1 in location 5, right? Easy peasy. Otherwise, I want to turn off the LED, so I'm going to have to do something slightly different, right? So I'll have to do, I want to do else GPIO, that's not right, D, there we go, GPIO D, PDOR. I want to clear it, so I'll do the same thing that I did before when I was clearing a bit. 1 shifted 5. So that turns it off. Okay, so this should totally work, right? Let's go ahead and build it and upload it and see what happens. Okay, it built. Let's debug it. All right, so it hit a breakpoint here. I'm gonna go ahead and hit play, and let's look at what it's doing, right? So here's my switch 1 right here. And my LED is going to be over here next to this little jumper. And if I hit the button, oh, it turned on, but it's not turning off. That's weird. That's super weird. Let's, That's really odd. Let's look at that schematic again. Ah, I see. So this switch, if you notice, there's no pull up or pull down resistor. This capacitor isn't going to pull anything in any direction because it's on the inside and it does it there. But when I close the button, it connects it to ground anyway. So this doesn't have a pull up. It should never be 1, right? I think actually what happened there, what we just saw, was some kind of electrical noise that just happened to trip across it. So, or it might have been my thumb connecting a trace or something like that. So that didn't work at all. So what can we do here? Let's look back at the reference manual and see what we can do about this. So I'm here looking at the pin control register for the port, and looking at some of these other definitions, some of these other bit fields. So here's the mux we've been modifying to get an idea of what it is that's happening here, right? So we've set it up as GPIO. That's fantastic. But some of this other stuff might be pretty interesting. So I'm going to scroll through here. Okay. So we have pull enable and pull select. So the idea here is that this particular microcontroller has internal pull up and pull down resistors that we can configure using software. So pull enable turns on these pull up or pull down resistors, and then pull select tells us the direction. So if I write a 1 into the 1 bit and a 1 into the pull select bit, this enables a pull up resistor. If I leave it 0, then it'll be a pull down resistor. I don't want that since it's already being pulled down when I close it. So if I build put it to pull up, then this should totally work, right? So I've got the value, I need to write a 1, 1 into the lower 2 bits of the port register. So back to my code, I'm gonna modify the port C writing, right? So I'm going to add in some new bits. I'm going to add in add in my mask. I'm going to clear the lower 2 bits. 1, 1 is 3 in binary, so that's why I'm putting 3s in these masks. And then I'm going to OR it (0x3). Or I could just OR it with 3. It doesn't really matter. It's all the same thing, right? And set mux bits, enable pull-ups. So this enables my pull-up on the pin and allows us to have the switch operate the way we expect it to. So let's try debugging this. Boom. Okay. So there we go. I'm going to hit run and let's see what happens. So again, I've got my switches in the upper corner here, and the LED that I should be turning on is over here next to the switch. So when I hit the button, it turns it on, and when I release it, it turns it off, on, off. Totally awesome, right? So now I've got a successful digital input, and that should totally work. Awesome. So to review, when we're setting up a digital input pin to work with a button, we need to enable the port clock gate just like everything else. We need to set up the port pin control as GPIO and to set the pull up enable and pull up direction bits. Then set my data direction, and then I can read from the pin. It's pretty much as easy as that.